Hello, this is Scholars Page, and this is part 4 of my YouTube series of my Java introduction course. In the last video, we looked at if and how condition statements work using if, else, else if, as well as checking out how Boolean helps in conditions. And we'll use some of that information for the loops that we'll discuss in this video. So again, I'll make a new class, which I've been doing in every single video. And in this case, I'll name it loops. And I guess in this case, we can do it automatically because I'm sure by this point, you will know how to use the shortcut or write the main string by yourselves. But this is just a quick way of adding the main string, but it's useful to know actually how to write it when needing to write on it on a computer or on a device which does not give you the shortcuts. So I finished making the class and it tells us that it has been auto-generated, but we don't need this. So how a for loop works is that we write for, we have brackets, then we have semicolons, and basically it's if checks for this condition. If this condition is true, this action shall happen. And let's just write the code. What will happen if let's just say hello, what will happen if the condition is true? This is just so we actually have a code to run for the loop. And actually why it's giving us an error is that typically in for loop we have two semicolons that are inside of it. Now you see the error has gone away, and this is because actually there's three parts in a for loop which are run before the code and which are actually executed in order for the code to run, and actually which code it will choose and when to run that code. So actually, since we don't have anything in here, it's blank, and we run it, you'll see it will be run infinitely, and I'll have to stop it by pressing the terminate button, which is right here. Now actually how for loops work is that you actually declare and initialize a variable at the start, and let's use int I. The letter I is very traditional and commonly used for loops, and all loops, equals to 0. We have initialized our variable, and this is the first part of the three-part for loop let's say statement. The second part of the statement is the condition that will help in running the code. So the condition will allow the code to run as many times as the condition allows. So let's say the condition is I is smaller than 6. That's the second part of the statement. The third part of the statement is what will happen after every single loop and which action will be performed to continue the loop at the end. And this actual part of the statement helps us to do the loop for multiple times, and it actually helps us to understand when to stop the loop and when to keep doing the loop. So it basically puts a cap until what point will the loop be done. Again, the second part of the statement also does this, but this is what actually makes it happen. Now I'll write I++, but what this actually means is that I'll write it out. I equals I plus 1. So the value of I is taken and added plus with 1 and then put back into the value of I. So the new I is the previous I plus 1. Now the easy Java shortcut way of doing this is just writing I++, which basically says that I will be incremented or increased with the value of 1 every single loop. Now if we run this for loop, you'll see we can do we wrote hello 6 times. This is because it first initialized the variable I equals 0, which will be done only once before any of the code is run. Then it checks the condition 0 is smaller than 6. This is true, so it runs the code, after which it does the operation of I++, so it changes 0 to 1. Now, again, it does not need to initialize. That only happens at once at the beginning of the code. Now it checks the second loop. It's I1 is smaller than 6. It is true, so it does it a second time. It does the code a second time, and then proceeds to do the increment, which is 1 plus 1 equals 2. And it continues checking the condition and then increasing until I equals to 6. And since 6 is not smaller than 6, it will stop the loop. Now, also what we can do is do a complex system println, where we do the value equals to, and then we do plus I. Now, in this case, what will happen is that every loop, the value of I changes. So every loop, the I, which is displayed with this message, will keep changing and adding on 1. So if I actually run it, you can actually see that will go all the way from 0, which is the starting variable before any of the code is run, the initialized variable, and goes all the way till 5, after which 5 plus 1 equals 6, and 6 is not smaller than 6, which breaks the loop. Now we can actually use the if condition to actually break the loop in between, where we write if I equals, let's say equals the value of 4, we write break and then semicolon. What the word break does is it stops the loop and stops it dead on its track, and there will be no more loops after this point if the condition is met. So in this case, since we got the number till 5, and if we now run it with this if condition, you can see the value of 4 is the last point at which the loop stops. This is because when I becomes 4 and 4 equals to 4, the loop has been broken, and this was performed the last time, which was the 5th time. But also this can work at the end, where if I put it after the if conditions, this will mean that if the break happens, the code of printing out this value will happen after the break. So this code, it will not get to this point that it will run this specific code. So if I run this, you'll see that it only displays the value of 3. So since 4 is smaller than 6, which is the condition for the loop, but 4 is also equals to 4, which breaks the loop, even though the condition for the for loop is correct, the if condition prevents this piece of code from actually activating and giving us the next value. Now this is for loop. Now for while loops, what we need to do is, let's erase the for loop. What we need to do is actually declare a variable. So let's say let's say in C equals example 3. And how while loops are written is that there's while, and then there's a condition, and then there's a code that is run if the condition is true. But the code is run while the condition is true. This keywords mean that until the condition turns to false, the code will keep executing every single time. So as long as the condition is true, the code will keep on running and there will be no stopping. An example of this is if I write C is smaller than let's say 7, and the process that will happen will be value, which will be text form, value plus C. So if I actually run this, this is actually an infinite loop, and it will keep doing value as 3 until I press terminate. It will keep on going. This is because the condition of C smaller than 7 will always be true, and since we don't have any other code which will change the value of C, this code will run infinitely, as you see in the box or the console. Now, to prevent this from being an infinite loop, what you can do is write C equals C plus 1. Now, what this will do is that since the while condition, the condition inside of while is true for some time, say, because every time the loop is run, the value of C changes. So it's similar to for loop in the case that it needs to check the condition at the start of the loop every single time before continuing to loop, and if the condition is not true at some certain point, the loop also ceases to exist and the loop will stop. Now if we run this, it will actually go 3, 4, 5, 6, and it will actually display this code 4 times, which is correct because you can see that the difference between the value of 7 and the value of 3 is actually 4, which is why the console displays 4 times the code we have written. Of course, while loops are more easier than for loops, since they only require one piece of condition that activates the loop. The reason why programmers usually prefer to work with for loop is that it has one specific order of how the loop is run rather than just one condition being true. A condition needs to be true in order to activate the code, but the while loop, just as long as one condition is true, the loop is run infinitely, which is why a lot of mistakes can happen if you are using the while loop, and that's why programmers typically like to use for loop. But of course, while loops can also be very useful in cases where one condition is always true, but you need to actually find out where there's an error. Where, for example, in a school's counting book, if there's any numbers which are smaller than 100, it seems like there's been someone who has stolen money, because the transactions always happen over the course of over the value of 100, in which case it will be if any value is lower than 100, then the loop will stop, and you can see that actually in this specific point the loop stops, and this is what's wrong. This is typically used to find bugs, but that's it for while and for loops and how to use them. That's it for this video, and thank you for watching.